Hello everyone, I'm back with another video. Firstly, we covered arrays, so a slight revision. This is how we created an array in C, and we have different dimensional arrays. So in 2D, we can initialize using this, and we can also calculate the address of each and every items of an array. And let's talk about HashMaps. So why did we need HashMap? So HashMap is basically needed for sorting. Let's take an example where HashMap is not used and what is the difference it creates after uh, using HashMaps. So let's talk about linear searching first, slightly. Okay, in linear search, everything is stored in an array and in the fashion that they are totally random. So in linear search, what happens is we need to look each and every element from left to right. So for searching, if I want to search 16, I can't just directly jump here because I don't know the index. So index we talked about, uh, this is 0, this is 1, this is 2, this is 3, and this is 4. So we don't really know the index, so we can't just get the element in order of 1. So this is linear search, so the order is order of n. That means we go of n. So that means we need to go sequentially from left to right. We just look 6. Oh, it's not 16. We move to the next index. 3, it's not 16. And another, okay, 16. We found it. So this is how we do the linear search. Now, what is so special about HashMaps? Now, this is important. So if I need to store the same elements, okay, so what we can do is let's make an array that will fit these items or the keys such that the key of an array matches these values. So what I'm trying to say is if I have the array of length 17, let's say, okay, so this is an array of length 16. So what we can do is we can just simply put this value in this key, the same key. So in this case, the key and the value is same. So I can put 6 here, I can put this 3 here, I can store this 16 here, and I can just store 11 here, and I can store 7 here. So what is so good about this type of structure or this type of data structure, that is the hash maps, is that I can just search the items in the order of 1. How? Because we actually know the index, because the index is just equal to the value. So if I'm going to search 3, then I'm just going to look at the index 3 and I get the result. So order of 1. If I want 16, I just have to look the index 16 or the key 16 of an array so that I can get the result or get the item 16 in order of 1. Hash maps, they have this advantage of searching in order of order of 1, but is there any disadvantage? Okay, there is, because what if my next value was 100? So I need to create an array that will fit 100 such that the value and key has to be the same. So we need at least the array of length 101. But we just had 1, 2, 3, 4, 5, 6 number of elements, and we need the array of length 101. Wow, like we successfully wasted so much memory, and memory, it's very important. So the key is you just have to use less memory as possible. So what we can do, like, this thing is not working because it's not efficient. So we have different functions in hashing. So this this thing, what we were using, we're just taking the key. So this is the key space, and it is just using this function h(x) equals to x. So this hash function is just taking the key and outputting the same key, so that we can just store it in the key with the value same as that of key. This will look like this. So this is the simplest kind of hashing. And now what we have to do to overcome that storage issue, we just have to modify this function. So how are we going to modify this function? So we just define the function as x, and we just use this modulo function with the size of an array. So this size of an array, we can decide now. If we think that if we need the size of an array to be only 17, like we had in the first case, then now let's define it, or I can just copy. Yes. Okay. So this these are the indexes. Let's these are years, and then these are value. Okay. Now we are good. Oh, now for storing the same element. Okay. Now if we have to store the same element, we can just run this formula. So the array of size 17. So here, uh, h of 6, it's basically 6 percentage 17. So it's equals to 6, because the modulo we will get 6, right? The same thing if it's 3. So previously what we're doing is we're doing the same thing. We were using the length 17 array, and we are just trying to give the values on the basis of keys. The main problem was when we had this larger value, we just needed larger array. But in this case, if we have this larger value, we are going to do this formula. We'll get 15. Okay. What we are doing is we got this 15, and our life is so easier. So because we just have to maintain this area of small length that is on 17, we don't need that 101 size of array, because 100 just appeared. We just can do this. We can just fill it according to this formula, so that we will get the same thing up to there. And this, and for 100 we just didn't need 100th index, we just need this 15. So here I can just write 100. Okay, in case of 15th index. So wow, life is going great. We just can use smaller array, and we just save a lot of memory, and we can like store 100 even in like smaller array. Life's going good. No, life was like going great until we get here another item that is 15. Oh, whoa, whoa, whoa. Now what we will have is Just see, if you apply this formula, we are going to get this, which is equal to 15. So 15 is like, okay, 15th index, it's my place. What is 100 doing there? Now this is a collision. 15 also wants to stay in this position, and 100 is already in this position. So looks like this idea, it's not as optimal as we think. So what's happening? We just have to change the function to from 1 to 1 to many to 1. So now we have successfully found the collision, and our next step is obviously going towards the step how to solve this collision. I'm going to keep this collision thing for the next video. So for this video, we just learned how the HashMap made our life easier, and some disadvantage that we faced using the HashMap, and we nearly solved it using this technique of by just modifying the function, using this function instead. Life was going great until we got this 15. There is collision. So for now, this was for this video. If you like this video, give a thumbs up. If you really like this video and it's interesting, subscribe my channel, and bye until the next time.